Hello everyone, welcome to my brand new YouTube channel. So first of all, I hope everyone is keeping safe and well. With regard to maths, to get us back into the flow of things after the break, we're going to be looking back over the probability we've already covered, and in the next couple of days we'll be moving on to some new stuff, and I'll be using a mixture of videos and live lessons to help you out with those. We've been talking about probability up to now, and probability is all about the chance of something happening. So you might remember that we were talking about the chance of it raining tomorrow, the chance of rolling a 6 on a dice, or the chance of tomorrow being Tuesday. All of those have probabilities, or the likelihood of them happening. Some of the key words we had in probability was a trial is flipping a coin, rolling a dice, or picking a card. That's a trial to doing something. An outcome is the result of the trial. So if you flipped a coin and you got a heads, that's your outcome. If you rolled a dice and got a 4, that's your outcome. A sample space is a list of all the possible outcomes. So on a dice, the sample space will be 1, 2, 3, 4, 5, 6. On a coin, the sample space will be heads or tails. And then the event is the outcome that we're looking for. So if we need to roll a 6, the event is a 6. And then everything else is not a 6. We then had the fundamental principle of counting, FPC for short, and that's a fast way of finding the total number of outcomes from something. And the fundamental principle of counting is written as M multiplied by N. So the number of outcomes for the first thing multiplied by the number of outcomes for the second thing. And we have an example here where a restaurant has 3 starter options, 5 main course options, and 2 dessert options. How many meal combinations are possible? Well, they have 3 options for the starter, they have 5 options for the main, and they have 2 options for the dessert. So we multiply all those options together. 3 times 5 is 15, 15 times 2 is 30. So there are 30 possible meal combinations. And that's the fundamental principle of counting. You just multiply the number of outcomes for the first thing by the number of outcomes for the second. Then listing outcomes. So we had 3 main ways of listing all the different outcomes. The fundamental principle of counting, we were just interested in how many outcomes are there. We didn't have to actually go through and name every one of them. Whereas if we're listing them, we would have to name them all. And that can be quite slow. So we have some different ways of doing it. The first one is systematic listing. So you list out all the possible outcomes. So here I have how many ways are there to arrange numbers 1, 2, and 3. Well, you have 1, 2, 3, 1, 3, 2, 3, 1, 2, 3, 2, 1, and so on. There's 6 of them altogether. And I had a system. The first one I started with the number 1, and then I arranged the second 2 numbers. Then I had started with the number 3, and I arranged the second 2 numbers, and then I started with the number 2 and arranged the second 2 numbers. So I had a system that I followed so that I didn't miss any of them. Two-way tables is the next type. So a two-way table is when you have 2 trials. So like flipping a coin and rolling a dice. That's 2 different trials. Or maybe you're flipping a coin twice. So you'd flip it the first time and you'd flip it the second time. That's 2 trials as well. Here we have how many combinations of the letters A, B, C, D and numbers 1, 2, 3 are possible. So I put the letters A, B, C, D across the top and I put the numbers 1, 2, 3 down the side. And then we fill in the two-way table. So the first one we'd have will be A1. And then underneath that we'd have A2. And underneath that again we'd have A3. In the second column, well, the letter is B. So we'd have B1, B2, and B3. Third column, the letter is C. So we'd have C1, C2, C3. And in the fourth column, the letter is D. So it'll be D1, D2, D3. And that's your two-way table. You're after listing out all the possible outcomes there. And there's 12 of them. And the last type of way of listing outcomes that we only briefly looked at, and you don't have to worry too much about the 3 diagrams just yet, but these are the 3 diagrams. So these are really useful for when you have more than 2 events. So here in my example, Paul passes through 3 sets of traffic lights. What are the color combinations he could pass? So if it's 3 sets, that means we can't use a two-way table, so we need to go to a 3 diagram. Well, in the first set of traffic lights, Okay, so with the first set of traffic lights here, it could be red, it could be orange, or it could be green. Then we move on to the second set of traffic lights, and this is when it gets a little bit more complicated, because he could have come through red on the first set of traffic lights, and then he could have met red on the second set of traffic lights. Or he could have got red on the first set of traffic lights and orange on the second set, or red on the first set and green. Or maybe he didn't get red on the first set of traffic lights at all. Maybe he got orange on the first set of traffic lights and then red on the second set. Orange on the first set, orange on the second set, orange on the first set, green on the second set. Or maybe it was green on the first one, green and red, green and orange, green and green. And they're all the different possibilities for the second set, and then we threw in a third set of traffic lights. So altogether then he could have got red, 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 orange, red, red, green, red, orange, red, red, orange, orange, red, orange, green, if I'm listing off all the possible outcomes along the side. And counting them all up, there's 27 possible color combinations. So it'll be very easy to miss one of them if we're using systematic listing, but with the tree diagram, it really helps us out to make sure we don't miss any. So that was just also then, I'm going to cut across to our probability scale that we also looked at. Okay, so here's our probability scale. So you remember looking at this, that on a probability scale, all trials have a probability that go from 0 to 1. If it has a probability of 0, it is impossible. It cannot happen. And if it has a probability of 1, it is certain. It is most definitely going to happen. And that can also be written as percentages. So it could be 0% and 100%. And they're interchangeable. So you can use it as a decimal or as a fraction or as a percentage. Flipping a coin has an even chance. So that means that the probability of getting a heads on a coin is 0.5, and the probability of getting a tails on a coin is 0.5. The day after Friday is Saturday. Well, that's certain. That's always going to be the case. So it's going to have a probability of 1. And it will rain tomorrow. It is quite likely it's going to rain tomorrow. So it has a high probability. So we're going to say it has 0.8. So it's greater than even chance, but it's not certain, but it's quite likely. So 0.8 or 80%. If we talk about fair and biased then, a fair trial is when each outcome is equally likely. So like on rolling a dice, it's equal chance. So you're just as likely to roll a 1 as a 2, as a 3, a 4, a 5 or 6. You can get any of them. They're all equal chance. Or flipping a coin is equal chance because you're either going to get heads or you're going to get tails. And you're just likely to get either one. If you think of winning streak, like the big wheel that they spin, that's not even chance because some of them are actually bigger than the other ones when they spin it around. So you're more likely to get some of the lower prizes than you are to get some of the bigger prizes. Or some prizes appear more often on the wheel, so that makes it more likely to happen. If we think about it then, who would benefit from using a biased coin or dice? Well, someone that was trying to cheat you. So if you had maybe like a magician that was trying to do a trick and he was like, I'll always roll a 6, he might have a special dice that always landed on a 6. Or if you're in a casino and you were trying to roll 6 or roll 1s, you might have special dice that you're trying to do that. So people, especially when there's money involved, will try and come up with a way to get their hands on it. But that's kind of a quick recap on all the probability we've done so far. Hope you found it useful. Talk to you soon.